certifies model rocket hobbyists. The payload is any material that is on a rocket that's not necessarily part of the rocket. For example, you can have an altimeter bay like I have here on Strike, or you can have scientific payloads, or really anything that's not related to putting the rocket up there and bringing it back down. And the drogue is a term that we use to refer to a smaller parachute. In some cases, you'll have more than one parachute on a rocket, and if this is the case, the drogue is the one that comes out first. It's usually smaller than the main parachute, and it slows the rocket down so that when the main parachute comes out, it isn't ripped to shreds by the high speed of the plane. And then, of course, an altimeter is an electronic device which measures the altitude of the rocket. And altimeters that are commonly used in model rocketry will record the maximum height of the flight. Now, this is a typical model rocket. As you can see, it's got some basic systems on here. Very important, of course, are the launch lugs here, which you use to attach the launch rail. The fins, of course, which we talked about, which are basically there to balance the aerodynamic and gravitational forces acting on the rocket so that it can maintain a straight direction in flight. And then you have the engine, of course, which is electrically ignited at the start of the mission. And some recovery wadding at the top of it so that when the explosive charge at the end of the engine is ignited at the end of the flight, the recovery system, which includes the parachute and the shock forward gear, will be pressurized and ejected out of the nose cone so that they can successfully deploy. Now, Matt and Lindsay here and Will are going to assist me in describing the model rocket flight profile using frozen periods. Now, the first step in any model rocket mission is, of course, loading it onto the launch rail and setting the electric match inside the engine so that it can be ignited. Then once you're at a safe distance, you can set it to go off. And once it does that, the engine will start burning and it will begin to accelerate upwards. Now, eventually it will continue to coast, and it will get to a point where the rocket engine will burn out. And at this point, it will still continue going up because the aerodynamic drag hasn't yet canceled out the total amount of impulse that's been applied to the bottom of the rocket. Once it does do this, it hits apogee, and then the rocket will begin to tip over. At this point is usually where you will want to deploy your drogue. The rocket will come apart like that and begin coasting downward on the drogue until it gets to a predetermined altitude, which you can also set on your altimeter, and the main parachute will come out. Finally, and the hope is that once you have all these parachutes come out, the rocket systems won't tangle up with each other and they'll coast safely to the ground. Now, in case you're wondering a little bit about rocket engines, this is what a basic model rocket engine will look like. It's basically a cylinder solid rocket propellant with a hole in the middle. And basically, the hole in the middle is there so that the entire surface area of the rocket engine can burn. This creates a larger surface area than if you simply try to burn it like a candle from one end to the other. Now, the more propellant that it burns, the more gas is generated, and obviously the more thrust at one point in time. Now, rockets come in several different classes. Motors of classes A through G are small rockets that you can do for a class project where everyone would fire off a rocket at the end of the term or what have you. There is a method to these letters where what will happen is for every motor class you go up, the amount of propulsion will double. So Class G will end at 160 Newton seconds, whereas Class H will then be 320. So motors between Class A and G are commonly available on the market. However, once you get into Classes H and above, you require certain levels of certification from the NAR. Now, motor classes H through J are level 1, and level 1 is the simplest certification you get. Motors K through M then qualify as a level 2. The full configuration of Frozen Fury will be a level 2 rocket, as well as all of the test, 2 of the test launches that we did with the main strike rocket have also been level 2s. The more recent flight of Strike and the final flight with our main N motor and 4 N clusters will be a level 3 flight, and that is the highest level of certification that the NAR currently has. Now, there are many different types of motors aside from the composite motors that we've used for solid rocketry. Composite motors, of course, we're talking more about solid propellants. They come in classes A through Q. If you get much larger than that, you're not dealing with hobby rocketry anymore, you're getting the actual space programs. So, hybrid motors is a field of intense development in recent years. If you heard about Spaceship One, the first private spacecraft, that was a hybrid motor. They used rubber fuel, which is a solid, and then nitrogen oxide, which is a gas, as their oxidizer. And the thing about hybrid motors is that they combine the storage ability of a solid rocket with the ability to end the burn like you can do on a liquid engine. Now, a liquid fuel motor is commonly used in large space programs. Saturn V, for example, used kerosene and liquid oxygen. The new Chinese Long March rocket uses nitrogen oxide and hydrazine. And your basic liquid rocket will look like this. It will have the fuel and oxidizer in separate tanks, pump them into a combustion chamber where they're ignited, and then expel the gas out through a nozzle to generate the thrust. Now, in any rocket program, it's important to think about safety. It's important to have the appropriate level of certification from the National Association of Rocketry if you're doing a flight big enough to qualify for certification. Another concern is that whenever a launch takes place, the FAA has to be notified. What you'll do is you'll call the flight service station and they'll issue a notice to airmen. And you have to do this at least 24 hours in advance in order that they could post the NOTAM and everyone knows about it, so you don't have planes flying around in the area. But even if you do this, it's still important to keep someone who's watching the sky so that you don't hit any planes when you're launching off rockets. Also, in rocketry, there are several hazardous materials. You're dealing with high explosives and in some cases corrosive or caustic materials. So it's important to be aware of all the chemicals being used because otherwise you can get hurt. Also, when you get to the launch site, you're going to need to make sure that you have a plan to deal with fires, that you have a plan to deal with the engines and the propellants, and that you know who is in charge of dealing with emergency situations so you don't run around wondering who has to deal with this. At all times, it is important to use caution and follow all safety regulations. And with that, I will turn it back over to Matt, who will talk about North Dakota's present rocket programs.
So, two of the main programs